Hello everyone, welcome back. So guys, in this video we'll be learning how we can fine-tune one large language model with the help of parameter efficient fine-tuning process. Okay, so in our previous video I think I already showed you what is fine-tuning and why it is required and how we can perform the fine-tuning. Fine. So here we'll be fine-tuning one large language model called Meta Llama 2. I think you know Llama 2, right? Llama 2 is a large language model. So if you go to the Hugging Face and if you search for Meta, Meta is having different large language model. If I show you, let's say if I go to the Meta LLM, see, it is having different large language model like Meta Llama 3.1, Llama 2 is also there. If I expand all the things, see, this is the Llama 3 family, this is the Llama 2 family. So the way actually I'm doing the, let's say, fine tuning of Llama 2 family, you can also perform Llama 3 as well. Why I'm taking Llama 2? Because it would be a little bit, small size model. That's why I'm taking Llama 2. You can also take Llama 3 as well. Okay, the process will remain same. And how to get the permission from the Llama, I think I already showed you in my open source large language model session. So you have to apply for the permission first of all, and they will give the permission. Then after that, you can load it. And if you're not getting the permission as of now, what you can do, I can also show you one alternative approach. You can also follow this one. Fine. I think I already showed you one alternative approach, like you can use any other repository to load the model. It is also fine. Then what you can do after fine tuning this model, you can also push this model to the Hugging Face hub. Let's say if I show you my hub now, so if I go to my profile, see, I already published one model, this fine tune Llama model. After fine tuning it, I publish this model in my Hugging Face hub. Now people can use my model. So they will be just copying this name and they can use my model. You can see it is already downloaded 65 times. Okay, 65 times this model got downloaded by the audience, right? So that's how actually you can also publish your model. If you want, you can also publish your model to the Hugging Face hub. Got it? So that people can also use your model. Got it? So now let me show you how we can perform the fine tuning. For this, I have prepared one beautiful notebook. So in this notebook, actually, I have written each and every step you need to follow. So first of all, make sure you selected runtime as GPU because you are doing the fine tuning operation and definitely you need a GPU. So I'll be selecting T4 GPU because here I'm using free Google Colab. You can also take the premium subscription of the Google Colab. If you're taking the premium one, so you'll see that your training would be a little bit faster than this free one. Fine. Now let me connect this notebook. So guys, as you can see, my notebook is connected. Now the first thing what you have to do, you have to install some of the required package. So here I have listed down all the package actually you need, like let's say Accelerate, then PFT. PFT is the parameter efficient fine tuning that package. Accelerate you need if you're using transformer library and if you want to, let's say, use the GPU, that time actually you need to install this Accelerate as well. Fine. Then you can see bits and bytes is also requirement of the transformer. And if you want to set up everything in your local machine, that means if you're having local GPU, but if you don't know how to set up the GPU, no need to worry. I have created one dedicated video. Let me show you. So if you search my YouTube channel DS with Bappi, so here you will see that I have created one video in the video section, set up NVIDIA GPU for the deep learning. So here I showed you how we can install the CUDA and CUDA toolkit. So definitely, first of all, you have to set up your GPU in a proper way. Then you will be able to set up everything. That means you will be able to utilize your GPU. So make sure if you are doing local setup, you can try to watch this video. Okay. Otherwise, if you are doing on Google Colab, try to do the same thing the way actually I'm doing here. So let me install all the packages. So guys, as you can see, installation is completed. Now the second thing, you have to import all the necessary library. So you can see I have imported all the necessary library like auto model for casual LM, auto tokenizer. Okay, I think you already know these are the thing. The Hugging Face actually library. Okay, why we need it. Then you can see I'm importing something called PFT, that means parameter efficient fine tuning. So from PFT, I'm importing something called LoDA. You can also use QLoDA, but here I'm using LoDA. Okay, so both technique we can use, it's up to you. So let me import as of now. So whenever I will be using it, I'll tell you, okay, what are the package actually you are using and for which task. So see guys, execution is completed. That means everything is working fine. Now, let me show you the data set first of all. See, this is the original data. So let me open the data. See, this is the original data. So the data set name is Open Assistant. So the data set name is Open Assistant Guanaso. I think this is the data set name. And you can see this is the data. That means it is having some conversation between human and assistant, you can see. So conversation between human and assistant, you can see human and assistant. So this is the human, let's say conversation, and this is the assistant conversation. Okay. So that's how actually they have collected this data, and it is having actually, you can see how many example in the training you are having 9.85k rows. Fine. Almost 10k example you are having. Now see, it is also using different language. See, different language actually they have collected the data. Not only English, it is also they are using Chinese language also. They're using different language. That means it is a multi-language data and it is a conversation data. So we'll be training one chat model, that means llama to chat model. Okay, I think I already showed you what is the difference between llama to chat model and fine-tuned model. Let's say if you want to only perform the text generation, that time you can use pre-trained model. Okay, and if you want to perform, let's say, chat operation, and let's say all kinds of tasks, the way actually you perform with the chat GPT, that time you can use chat model. Now if you open the Hugging Face and if you go to the actually llama model, you will see that it is having different model. Let me show you. So if I search for llama, see if I go to the llama 2 series, actually llama 2 family, you can see it is having llama 2 7B model, HF model, and it is also having something called chat model. You can see chat model. Chat model means you can perform the conversation, chat operation, the way you actually perform with the chat GPT, right? So we'll be fine-tuning one chat model. So that is why I'm using this chat dataset, conversation dataset. Okay, instruction. So these are the instruction. I think this one, see, this is the instruction human is giving, assistant is replying. So these kinds of dataset actually will be using. Now you can use any kinds of data. You just try to prepare your data, okay, in that format. You can also create a CSV file. So inside CSV file, in first column, you can write the human, let's say, conversation. In second column, you can write the assistant conversation. That's how also you can collect the data. Okay, it can be any kinds of format. So as of now, we are using the data from the Hugging Face. You can also use your custom data. And how to upload your custom data to the Hugging Face? For this, you can see Hugging Face documentation. They will also give you the let's say entire process, like how I can, let's say, publish my data to the Hugging Face app, and from there I can load my data. It is also possible. But most of the data actually we'll see from the Hugging Face itself. We can use it from there. So see, this is the llama 2 supported data. That means whenever you will perform the fine tuning, so you have to convert this data in that format. See, this is the format. So first of all, you have to give the S token. You can see S token. Inside that, you have to give the instruction. And what is the instruction? Instruction is nothing but it's a human conversation. Whatever conversation human is doing, this is called instruction. See, if I open this example, see, this is the human. See, this is the human conversation. Okay, see, till this token actually, that means /inst, that means instruction. This is the human conversation. After that, whatever text you can see, this is the assistant conversation. Okay, this is the assistant conversation. Got it? So that's how actually you have to prepare your data, and at the last your S token will end again. Okay, that means this is the complete system token right now, the complete prompt. That means you are creating the prompt here, because my large language model supports prompting, right? So that means we are creating the prompt here, so that my model can understand whenever we are doing the inference, whenever we are, let's say, sending any kinds of prompt to the large language model, it can automatically understand we are sending the prompt. Okay, so that's why I'm first of all teaching my model. This is instruction, and after instruction, whatever actually message you can see, this is the your output. That means your response, assistant response. Okay, this is the format. Now if you open any kinds of data, you'll see that it is using the same format only. Okay, same format only. So we have to convert our data, this format to this format. Okay, now you can ask me how to convert this format to this format. For this, we can use one notebook. See, this is the notebook, guys. Even I already attached this notebook link inside this original notebook. Let me show you. See, this is the notebook. Okay, so in this notebook, actually, I already written one function, transform conversion. So this one actually will take the human conversation as well as the assistant conversation, and will add these at the token. Okay, like that, the way actually I showed you here. Okay, I think it is clear. Now you can use this function as it is, and you can convert any kinds of, let's say, these kinds of conversation data to your like LLM format. That means your llama 2 format. Now there are so many large language model. It takes actually different kinds of format. If you go to the documentation of the Hugging Face, you will see that what kinds of format they supports. Based on that, actually, you can actually write the converter. Also, you can get this converter from the Hugging Face itself. Hugging Face also provide these kinds of converter. You can use this converter to convert your data to a specific format. Okay, so most of the large language model will follow this format only. Okay, we'll see that most of the large language model will follow the same format. The format actually I'm using here. Fine. So that's why you can use this converter as it is. Now see, here I'm loading the data. That means my entire data. That means this data, this Open Assistant data. You can see I'm giving the name of the Open Assistant. Then see, instead of taking all the data, all the, let's say, 10K example, I'm only taking 1000. Okay, 1K actually example, because here I'm using free collab and fine tuning will take time. That's why I'm only taking 1000 example to perform the fine tuning operation, and I'm doing the, let's say, conversion operation. Then after that, I'm just pushing this let's say data here. So this is the data. Now see, the same data, but here actually this guy is taking actually 1K example, and he has already converted this data to the required format. Okay, so this is so this data is already available. You can see this guy has already converted this data to this format, so directly you can use this data. But if you want to do it, so this is the notebook you can use. Okay, the same notebook you can use. Got it? And if you want to use the entire data, guys, what you can do? So here I've already given the complete reform dataset link. You can open it up. So see, it is having actually 10k example only. See, around 9.85k rows. Now see, it is already formatted. Okay, it is already formatted. So you can also use this data. If you're using good configuration PC, you can use this data. Okay, for the fine tuning operation. But I'm going to use this data actually, 1k example data. Okay, only 1k example I'll be taking here. So guys, I think now you got to know how we can reformat our data for the Llama 2 model. And see, here we are using free collab, and free collab actually offers 15 GB of graphics card. If you see here, it will give you 15 GB of graphics card. See, okay, and here you will get disk around 112 GB, and RAM actually will get 12 GB. Okay, so this is the configuration of our free collab. Now here you can see it is having actually limit resources, barely enough to store Llama 2 7B words. That means we can only use 7 billion Llama 2 model. Okay, 7 billion Llama 2 model. If you're using 70 bay, 30 bay, 13 billion, that time actually will get difficulties. Okay, because it is a free Google Colab. But if you're using a premium Google Colab, that time actually you can also use this model. Okay, it's completely fine. Now here you can see full fine tuning is not possible. Here we need to perform the parameter efficient fine tuning technique, like we'll be using LoDa and QLoDa, because the full model we can't load yet. We have to use a quantization technique. That means we'll be using LoDa and QLoDa to perform the parameter efficient fine tuning. Got it? And to drastically reduce the VRAM, we must fine tune the model in 4-bit precision, which is why we'll be using we'll be using LoDa here, not QLoDa. We'll be using LoDa here. Fine. That means we'll be loading our model in the 4-bit precision. I think I already explained here what is 4-bit precision, right? So initially your weight would be in the full precision. Okay, 32-bit precision. This is called full precision, and we'll be loading the model in the 4-bit precision with the help of LoDa technique. Fine. I think it is clear now. Now let's load the model, guys. Now you can load the official Llama 2 model. You can see you can also load the official Llama 2 model. So Llama 2 is having also official model. So this one. So see, this is the official Llama 2 model. You can load, you can copy, and you can just paste it here. But if you didn't get the permission, what you can do, you can also load the model from any other repository. So see, this repository has having this model also. This Llama 2 7B chat HF model. So this repository has already published. And here you don't need to take the permission. You can directly download the model. So if you haven't get the permission, you can use this model. Either you can use the official model. Okay, official model. Let me also copy here and let me mention it here. Let's say I can comment here just for your reference. You can copy the name and you can paste it here. Okay, later on. Now this is the dataset, guys, I'll be using. I think you remember. So this 1k example we'll be using. So copy the name and try to mention it here. Okay. And after fine tuning, what is the name you want to assign? I want to assign this name Llama 2 7B chat fine tune. And these are the LoDa parameter, you can see. And LoDa parameter wise, everything just keep it default, because you can see I'm loading everything in a 4-bit precision. Okay, 4-bit precision. So no need to change anything, keep it everything as default. See, I won't be changing anything. Only the change you have to do, the epoch size, number of epoch you want to train. So I think epoch I have mentioned here somewhere. See, number of epoch, training epoch. So as of now, I'm showing you one let's say epoch training, because one epoch training will take time if you're using free collab. And if you're doing the actual training, that time just try to increase the epoch size. Now everything keep it default, no need to change anything. Now let me initialize all the parameter. So this is my LoDa parameter, guys, for the parameter efficient fine tuning. Fine. Now we'll be loading the dataset. I want to use the training dataset because I want to do the fine tuning. And here I'm loading everything in a 4-bit precision, you can see. Okay, with the bits and bytes actually configuration, we are loading everything in a 4-bit precision. So this is the way actually we can define our LoDa. And how I got this code, if you go to the Hugging Face documentation, you will see that, okay, they have already given this kinds of code snippet. So you just copy paste and try to use it as it is. No need to change anything. Fine. Now see here, I'm loading the model in a 4-bit precision. So here you can see I'm loading the base model as well as the tokenizer. Okay, tokenizer I'm also loading. So guys, here you can see I'm setting all the LoDa configuration. After that, here is the training arguments. I think you know what is training arguments. In the Hugging Face, you have to set your directory, the number of epoch, your optimizer, everything you can set here. Then with the help of SFT trainer, I'm initializing the training process. You can see model.train. Now see, if I execute this code, it will start the training. But see, training will take time actually, around 30 minutes actually it will take. I was training previously. I know that it will take around 30 minutes. Okay, 30 minutes you have to wait because here we are using free Google Colab. So as you can see, it is downloading the model. After that, you will see that it will start the training. See, it's downloading the model. So see, I won't be waiting 30 minutes. what I'll show you, the next process actually you can follow. Like after training, what you can do, because see, I have written all the code, only you just need to execute if you're doing it, because here I'm recording currently, so I can't wait actually 30 minutes to train the model. Let me show you what you can perform here. See, after training the model, you have to save the model. You can see you have to save the model, trainer, model, save, pretend. Then you have to give the new model name. I think new model name, I think you remember, we have given a new model name here. Whenever we define all the configuration, this is the new model. Okay, so it will save with the help of this model. Fine. So it will save the model in the here in this disk. Actually, you'll see that it will create an output folder. Inside that, it will save the model. Then after that, you can also visualize the TensorBoard logs. See, this TensorBoard will show you the losses, then the accuracy, okay, of your model, everything. It will show you that means the complete metrics. It will show you the training losses, validation losses, everything. It will show here. Then after that, what I was doing, I was loading the original model. You can see I'm loading the original model, not the trained model I've trained. I'm loading the original of the Llama model, and then I'm testing with a prompt. What is large language model? I just wanted to see what would be the output from my original large language model, because that means I want to compare this result with my trained model, the model I've trained right now. Okay, that's why I'm loading the base model. That means my original model, and I'm only want to see the output. Okay, so here I've given a prompt. What is the large language model? And this is the actually output I got, okay, from my model. Then after that, what I did actually, I deleted all the model pipeline and everything just to empty my VRAM, because in RAM actually it will occupy lots of space. So you have to execute this code after executing this line actually. So no need to execute this line of code. Just try to skip as of now. First of all, execute this line of code. This line of code, what it will do, it will try to load your base model as well as your trained model. Okay, that means new model. Then it will merge. That means if you want to save the model right now, if you're using parameter efficient fine tuning, first of all, you have to load your base model as well as your new model. Okay, both you have to load. Then after that, you have to merge. After merging, what you can do, you can also load your tokenizer. Then you can push this model to the Hugging Face app. For this, just execute this line of code, and you have to perform the Hugging Face CLI login. Okay, Hugging Face CLI login, and it will ask for one authentication token. See, this is the token it will ask. Now, what you have to do, go to the Hugging Face, go to the settings. I think you know how to generate the tokens. Go to the access tokens. Now create a new tokens. Let's say I'll give the token name is equal to test. And now you have to give the right access, because you want to write something. You want to push something to the Hugging Face app. That's why you have to give the right access. Now create the token. Let's create the token. Now copy the token and pass the token inside that. Inside that, you have to pass the token, then give Y, then press enter. After that, it will automatically authenticate with your Hugging Face. Then it will be pushing your model to the Hugging Face itself. Now here you have to give your username. See, this is my username, ENTBAPPI. So make sure you are giving your username here. Okay, not my username. Otherwise, it won't be working. Okay, so if you execute this line of code, it will push your model as well as the tokenizer as well. Now, after executing this line of code, go to the Hugging Face, click on the profile, go to the, let's say, your profile. Now you'll see that in the model section, this model would be published. Okay, and this is the model, and this is your tokenizer. That means the same model you have to use for the tokenization as well. I think I already showed, right? Now, after that, let's test this model, okay, whether it is working or not. So for this, I created another notebook. Let me show you. So this is the notebook I created, guys, fine-tune model test. Now, again, just try to install transformer accelerate. That means all the required package. Then after that, just try to load your model right now. The model actually you have trained. See, this model, just try to copy the name and just try to paste it here. Okay. Then again, I'm giving the same prompt. What is the large language model? I'm loading the tokenizer first of all. So inside this pipeline, I'm giving my model. Then after that, you can see I'm creating the complete pipeline. Then it is predicting and it is giving me the results. Now see, this is the results actually I'm getting. See, although I've trained only one epoch, but if you see the results, it's not actually bad. Somehow actually it has given me the good output. Then again, I have given another actually prompt. Now see, this is the results. I'm executing my model and this is the results actually I'm getting. So the prompt is actually explain to me in a simple to understand way. What is the equation of finding the nth triangle number is and how it can be provided by using the high school level math. Please give each step of a proof of using LaTeX. See, this is the LaTeX actually output I'm getting. That means all the, let's say, mathematical equation and everything it has given me as a LaTeX. Now I can convert this LaTeX to the mathematical format and you can see that particular output. Okay, so that's how actually we can also test our model. And this is the entire process of fine tuning, guys. Entire process of fine tuning, and still training is going on. You can see still training is going on, and it has created the result folder. And inside result, inside branch, it will save the weights. Okay, it will save the weights. That means the artifacts. Fine. So yes, guys, that's how actually you can perform the fine tuning operation with the help of parameter efficient fine tuning. You can use either LoDa, either you can use QLoDa. Fine. So now what you have to do, guys, just try to perform this fine tuning. And if you're having any error, if you're having any issue, you can let me know in the comment. I'll try to help you with that, okay, to fix that particular error. Now, apart from that, just go to the Hugging Face, try to pick any other model, guys. Go to the Hugging Face and pick any other model. Not this Llama 2 model. You can also take Llama 3 model. You can also take, let's say, Mistral model, Falcon model, any kinds of model you can take. Just go to the model section. Just find a model and try to perform the fine tuning process. Okay, you can use the same technique to perform the fine tuning process. Fine. So in future, I will create some more video there. Actually, I'll show you how we can fine tune any other model as well. Let's see if you want to fine tune the Jimma model, how we can do it and all. Okay, we'll be creating some more video. But before that, first of all, try to explore by yourself. The way actually I showed you, the entire notebook I shared with you. Try to pick up any kinds of model and try to follow the same technique to perform the fine tuning operation. So with that, guys, thank you so much for watching this video. I hope you liked it. Thank you so much.